Hello friends. So here we take projection of solids. That's problem number 50. So here we have a cone of base diameter 40 and the axis length is 50 mm is resting on HP on a point on the circumference of its base such that its apex is 40 mm above HP and the top view of the axis is inclined at a 60 degree to the BP. So draw the top and front view and determine the inclination. Okay, so here it's a 40 mm base dial. Okay, so it is rest on HP on the circumference. Okay, so next here he says the apex is 40 millimeter above HP. Okay, it is 40 millimeter above the H. So here we need to find what is theta. Okay, next he says the top view of the axis. This top view is nothing but appears to be. Okay, appears to be is nothing but it's a no locus line. No locus line problem. Okay, so that is inclined at 60 degree to the VP. Okay, so normally if you take a cone, so when you see from the top it looks like a circle. Okay, so we need to start from the top view. So just to start with that one, so we'll take a X and a Y. Okay, so VP and a HP. So the diameter is 40 and the axis length is 50 mm. Okay, so they have mentioned the axis length is 50 mm. So now take a radius of 20. Okay, a 20 mm and draw a circle. Okay, so this is how exactly it is visible. Now you can just drop one horizontal, it's a thin lines. Okay, so one horizontal and one vertical. Okay, so then divide that one with the 8 parts. So that will be useful just to make sure that to drop the ellipse, that is the visibility in the second view. So 45 from here and 135 from the same point, and now just make sure that this will pass through the center point and to the angle. Okay. So here also just like this. Okay, so make this circle a little bit dark. Okay, so just to dimension that one, so we'll drop this one, it's a pi 40, and we'll start the naming from the right side. So A, so B, C, D, E, F, G and H. Okay, so now once you finish the top, that is how it is visible in the top. Now take the projection till the XY line. Okay, so now just complete the naming. Here it's a when we see from here, this is a dash. Okay, so this is a H dash in the bracket B dash. So this is a G dash in the bracket C dash, and this is a F dash in the bracket D dash, and this is a E dash. Okay, so this apex is nothing but O in the bracket O1. Okay, so here we can write O1 dash also. So now it is a 50 mm. So take a line from the O1. Okay, so O1 and just drop the axis line like this. And when you see the cone from the front view, it looks like a triangle. Okay, only the outer boundary. Make the outer boundary Okay, so this is how exactly it is visible. So just to make the dimension, you take a length from here and here. So now this is a 50 mm. Okay, so this is how exactly it is visible. Now what they say, the apex is 40 mm, means this apex, now it's a 50 mm. So here when we rotate this one like this, okay, this apex should be 40 millimeter above HP. For that one, first you need to take a 40 mm above HP, 40 mm above HP, okay, and you just need to drop one horizontal line, little bit. Okay, so take any one reference point somewhere here. Okay, so this is what we have taken, it's a 40. Okay, so this reference point is nothing but a dash. Okay, and taking this a dash to the o dash. Okay, so this is o dash, so a dash to the o dash line, from the a cut on the 40 mm line. Okay, so this a dash to the o, take it from the reference point, any reference point, and cut it. Okay, so now got this line. Okay, so say this is a dash and this is a o dash. Okay, so now we have these 2 points, we need this point. So what we'll do, we'll take a reference point from a dash to the e dash. Okay, so we'll cut one arc this side, and again, so from o dash to the e dash, from the o dash we'll cut one more arc this side. Okay, so we'll get this line and this line. Okay, so now this is our e dash. Okay, so now just take all these reference and you just cut from the both ends. So from here one line, so again the same length will remain here, cut one more. Okay, and then from the midpoint, one midpoint. Okay, just extend this axis line. This is center one is a axis line. Just extend till here. Okay, so just mark the reference here. Okay, the remaining we just leave. So this is a dash, so next one is h dash, b dash. Okay, so next one is g dash, c dash, and o1 dash. So next one is f dash in the bracket d dash. Okay, so now take a protractor, and from the reference point you just measure how much is the length. So we'll get around 25. Okay, so this angle is 25, so this theta is 25 degree. Okay, so now we are viewing this one from the top. Okay, so now to take the projections, so as we have take a rightmost, okay, and a bottommost. Okay, so then drop the vertical projections, one from here. So from each arc just drop one line. Okay, so like this. Now you say G and H, G and H till here. So this is A till here, and D and H till here, and it is the C. Okay, so you just extend this O1 line till here. Okay, so this is our O, and on this one this is a O dash, that is a O1. Okay, so now this is A. Okay, so this is a B, C, and a D, E, F, G, and H. Okay, so mark like this. So when you see from here, you can see the line which connects from O to E. Okay, so O to E here, this is visible, means a part, means this G and C. Okay, so it is something like a viewing from here. When you see from here, you can see only this part. Okay, that is G to C. Where is G here? Where is C here? Okay, so this part is visible to you. Okay, and the remaining G to C from this side is invisible. So invisible means it's a dotted line. Okay, understood? The same circle we have lifted like this, so it is something like weaving like this also, or weaving like this also. Okay, it is similar to that one. So this part is visible, so that is CDEFG. So CDEFG is visible, and this GHABC is invisible. Now, so this O2C will act like a boundary, and O2 G also. So just drop a tangent like this. Okay, so this is how exactly it is visible in the top view. Okay, so now appears to be means no locus line. So what we can do is take a reference point and take a 60-degree line. Okay, 60-degree, and just drop a line. Okay, so this is 60-degree. Okay, so now we'll take any one reference point here. So say that is O. Okay, so first we'll measure from O to E, extreme position, O to E, and we'll cut an arc. Okay, so this is our point E. Okay, and we'll cut one more O to A. Okay, so from O to A. So this is our A, this is our E. So we got these 2 points. Okay, in a similar way, you can take a O to C. Okay, so now when you rotate like this, C will come this side. So O to C will be here, and take a to C. Okay, so we have A here, we have C here. Okay, let's say this is a C. Okay, so now take a O to D. O to D. So from O, D will come this side. So again we have a E already. So from D to E. D to E. So this is our D. Okay. So now this part is complete. Now similarly we can do the same thing here also. So we'll take a O to G. Okay, so O to G will come this side, and we know E to G. E to G. Okay, so this is our G. Okay, so in between that one, from G we know how much is the F. So from G, how much is the F, and from E, how much is the F. From E, how much is the F. So this is our F. Okay, so now similarly you take a O to H. That is O to H will come this side, and so B will come from this side. Okay, so now so this arc we need to extend, that will extend. Okay, so this is our H. Alright, so remaining is a B. So we'll take a O to B. Okay, so now A to A to this is our B. So now, so from C to G is visible, so we'll mark this one with a continuous line, and from here A to G is invisible, so you can just take a dotted line. Okay, so like, alright, so now just drop a tangent. Okay, now just take the uppermost projection, that is a O. Okay, so just take a uppermost a little bit right side. Okay, and the rightmost. So rightmost F and G will come on us coming on a same line. So if they are coming also, need not to worry, just drop a one uppermost. Okay, so now take a horizontal projection from each line. So I place a long scale. Sorry. Okay, so now, so A is on the XY line, so you just drop A till XY, so this is A dash. So next is the B, so take a B. Okay, it is to the next line, so this is our B dash. So next take a C. Okay, so it is almost nearby that one, so careful. So this is our C dash. So next is a D, so D is on the next line, so just take a D dash. So next it will be E to the uppermost line. Okay, so this is a E dash. Okay, so next it's a F, so F and G are coming on the same line, so this is our F dash. So next will be G dash. Okay, so next will be H. So H is here. So next we missed one point here, so that's O to O1. O to O1. So just mark from here to here. There is a O1. So this is a O1, and so here it's a O. Okay, so here we have a D. Alright, so now when you see from here, the whole base is visible. So from A to the B, okay, to the C, to the D, and to the E, F, then on the same line G, then H, then to the A. Okay, so now to the O, it's like a tangent, one here, and one more from here. Okay, so from O to O1, one axis line. Okay, so here also better have that axis line. Okay, so here also have that axis line. Okay, so this is how exactly it is visible, right?